We'll have a 5-minute, this is for all the contestants too. After 5 minutes, you will hear a beep from the timer in here, so you can keep a track at the stage itself. And we will close the recordings dot after 5 minutes. And we will move at a really fast pace. So the next 40 minutes is going to be super fun. And let's look forward to it. We will start with our first talk with Tushar.
Yeah, do I start? Yeah, all right. So my name is Tushar, and I'm here to give you a quick sneak peek of Python 3.14. So for some context, Python, the current latest stable version of Python is Python 3.12. Python 3.13 will be coming out October of this year, and Python 3.14 will be coming out on October of 2025 if things go well. So it's a bit more than a year away, but the development has already started. So I wanted to give you a sneak peek of what you could expect from Python 2 years down the line. So yeah, let me go into Python 3.14. So I've already compiled a version of the latest Python version, which is as you can see, it's Python 3.14.0 alpha 0. Yeah, it's your regular old Python. But a couple of new things that exist in here are the fact that there are now lambda functions, which you can define with the arrow syntax. Something like so. So foo is now a function, and you can call it to get 1, 2, 3. You can also in fact do this. So people kept complaining that, hey, the lambda syntax, it doesn't really make sense. Can we get the JavaScript arrow syntax instead? So this has been added in 3.14. So yeah, yay. And yeah, glad to see at least one person enjoying this, but yeah. The other nice thing that has been that's already there is a way to talk directly to a language model. So at the language level, you can type AI, and you can simply start typing your prompt. So something like, what is the answer to life, the universe, and what? Everything. Let's see. Yeah, then it works. So yeah, Python 3.13 seems great, but the truth is I have been lying to you. This is not real. In fact, this is not even Python 3.14. This is Python 3.12. What I've done is this is technically just the regular Python interpreter. It can run files, it can even run projects. This is my foo.py file. I can do Python foo.py. That works. I can even it is a proper Python interpreter. It's just that I haven't really changed anything with the interpreter. What I've done is I've written the code that runs when you try to start Python. So what you can do is there's a way inside the Python environment to hook into the startup. Then it's called .pth files. .pth files are very nefarious. They can be very dangerous, and please do not run this code at your workplace. But it's it's possible to have code that runs when you start Python, without even telling the interpreter to run it. So basically this is a stringified version of this code, which uses the code module to start a custom interpreter. Then I'm simply intercepting the commands that if they start with AI, then sleep, then type thinking, and then type the answer is 42 and stuff like that. So, well, custom interpreters are actually very useful, and so are PTH files, but do use them in moderation. Do not don't do as I say, don't do as I do. But yeah, that's the demo, and yeah, thanks for listening.
Thank you so much, Tushar. Next up, we have Neil. Next up, we have Sai. And can we request Neil to be ready for the next round?
Yeah. Good afternoon, everyone. So my name is Kashyap. I lead the conversational payments, speech LLMs at NPCI. So I'll just try to discuss about how do you speak and pay. So we do have. So what is the volume of data that we handle at NPCI? So we have 6 TB of data that we generate every day. We handle 10.5 billion API requests. We do real-time fraud detection in less than 10 milliseconds. So every transaction latency is less than 200 milliseconds. To know about this, you can attend tomorrow's open space talk by my other colleague. Coming to how do we speak and pay? So most of the voice assistants, like first, how did they transition? We have Apple, Siri, first came up in 2011. Then you have Google, Google now. Microsoft has released Cortana, Amazon's Echo-related devices. You have Google Assistants. And then the other players like the cars like BMW have started integrating Alexa to their cars, and the integration and various other car makers also have started doing that. So how do these work? So how do the conversational payments work? And so typically we have so we take the user input and voice. And then we have a model called automatic speech recognition, ASR, which converts your audio to text. And then we have an NLP module, which consists of machine translation that translates, English. Like if you have another languages like Kannada, Telugu, Tamil, we have models built for English, but there are no other languages, right? So then we translate this particular language to English. And then we do some processing, and then we give the output as audio using TTS, text to speech, and that is given to the user. So this stack is built using Python only. So how did we build it? So we have a couple of products at NPCI. Like one is the Beam voice feature. In the Beam app, you can send money using your contact name. You can do balance check. You can open your QR using voice. 123 Pay is a feature phone. Feature phone for people who do not have a voice. People who do not have smartphones, but they want to do a UPI payment. So this is the stack that we have used. So we have bunch of audios. So the audios are, first we try to, detect, what the audio language is. So that is taken care by something called spoken language identification. If the user is speaking Hindi, English, we try to detect that particular audio. And then we have multiple ASR models. So Whisper by OpenAI is one of the stack we use. We have NVIDIA's NeMo. So we have a bunch of models. We see which is performing better for what language. And then we try to detect what the user is trying to say. Like whether the user is trying to say send, whether it's looking at transaction history, balance check, what the user is trying to do. And then we convert that particular model to, that particular language to English, if it is not English. And then we, we extract the amount and name and send it to the user. Finally, we are building more than this. So we are looking at a voice assistant, like using the generative AIs like LLMs, big word, that will be coming up soon. So that is, we are working towards more interactive speech. Yeah, thank you everyone.
All right. Thank you so much, Kashyap. Next up, we have Neil.
Yeah, this is fine. Can I start? Yeah, okay. Hi, I'm Neil. I work in AI by day, and then I dabble in back-end technologies by night to soothe my soul. So, this talk is just for me to put out some side project that I had that I think a lot of y'all might find interesting. Okay, so this might be a beginner mistake, but I've seen a lot of people make it. When you do async IO in Python, it does not mean multi-threading, right? But I just thought, why not, right? Because if you look at other event loops, if you look at Rust, if you look at what Zig is trying to do, if you have in Rust Tokyo, event loops can be multi-threaded, right? So what do I mean by event loops for anyone who is not too familiar? How an event loop works very basically is you have a ready list of tasks. You'll have a worker that pulls items from this ready list and runs them. It's at a high level, this is what it is, but as always, networking makes this a lot more complicated. With Python, as you all know, Python is not great with multi-threaded, the GIL and all that. In Python, the event loop has a single worker, right? But with Python 3.13, we now have the opportunity to disable the GIL with a build time flag. So I thought, why don't we try to make the event loop in Python multi-threaded? How easy is this? So I have written a whole blog about this. If you want to take a deeper look into this, I'll put a link up at the end. But at the basics, what I have done is, in the async IO library, which is part of the standard library of Python, the event loop that you all use when you say async or you say await, it is defined there. And it's built so that you can plug whatever you want. So when you use UV loop, for example, UV loop is using its own custom event loop. Now, why would you care? Why do you want to make async multi-threaded? Why would you want to write your own event loop? I don't know how many of you work in backend, but if you use Fast API runs all of their endpoints through async functions. Now, if we want Fast API to actually run more than one function at a time, it does kind of run multiple functions at a time, but it runs a single event loop that's running multiple events. So there's only a single worker that's running at a time. If you want to have multiple workers, what we normally do with UV loop or whatever is we would run multiple processes. But rather than run multiple heavy processes, why don't we just have our event loop run multiple threads, which is much lighter and much better scheduled by the OS. So if you have your own event loop and it can do multiple workers pulling from your ready list, your Fast API can have as many workers as you want without running multiple processes. So I have an existing event loop here. It's very basic. This is just for research purposes. If you want to try it out, I have it hosted on GitHub. You can go ahead and try it out. Right now, networking doesn't work great. That's because of how select works and how I've designed it. I've actually designed it with switching out the network from selectors to maybe IO uring. But right now it works. I wouldn't suggest you try to use this in production. I take no responsibility if your Fast API breaks. But if you're interested at all in writing your own event loop, trying to bring multi-threading to Python, multi-threading to the async event loop, you can email me, you can connect with me on LinkedIn. And if you want to read this blog, I have it over here. So the link will be here, but you can get to it from here. Yeah. I try to keep it as short as possible for a lightning talk. If you want to read more about what I've done, it's there in the blog. That's it for me. Yeah. Thank you so much,
Neil. Well, ahead of time. Next up, we have Vibhuti. And can we request Ananyadeep to be ready?
Hi everyone, I'm Vibhuti Rastogi and I'm a full stack developer at Indie. I'm here to share some simple yet effective techniques you can use for optimizing your Django application to boost the performance. So I don't think that, like, in my practical experience, if like you don't need an endless amount of time to just optimize your Django project. If you just focus on these 4 core issues, you will be able to handle 90% of your performance issues. So unoptimized database queries, inefficient use of caching, large or slow file handling, and poor memory management. These are just the 4 core issues you need to focus on. Now, the major performance issues happen in database queries itself, the way we query. So, I am sure you guys must be familiar with the n+1 query problem. It is that when you try to get the related object for the n number of objects you just queried previously. So, to remove this redundancy of queries, you can actually use select related and also prefetch related, which Django provides. And also proper indexing of the frequently used fields in database for searching, sorting, and lookups. If you do proper indexing, that also can boost the performance of your application. This is just some example code snippet how you can actually use select related instead of doing the n+1 queries over here. Then caching is also a very important part which it plays in your performance of your application. So I'm sure you would know what caching actually means, so I'll not get into that. And Django provides per-view caching and low-level caching strategies. So per-view would mean, like, if you have certain views where they are very database heavy, or those the data doesn't change much on those, and it is not user specific data. For example, product listing and your blog posts. So in those, like on those views, you can put caching, and that you can just use the cache page decorator, which Django provides. Low-level caching is like if, for example, you are using certain functions very frequently in your code base, you can just store the results of those functions and the database-heavy queries which you perform frequently in your code base, you can cache those as well. Next is efficient file handling. So if you actually, like the CSS and JS files which are there in your application, they also play an important role in the performance of your application. So if you just use gzip compression and white noise to serve those files, because white noise caches, like firstly it ensures to compress your static files through gzip, and then it stores in the cache so that it doesn't have to hit the disk every time it needs to serve. Secondly, like it's very important that you minimize your static files beforehand itself, before even the gzip compression, so that also helps as well. Next is, so actually it is very difficult to identify all these issues in real time, and especially the memory issues which are there in the application. If you install the Django debug toolbar, it helps you identify the memory issues in your application, the cache misses, the slow queries. If you just install this, it will be able to help you in like real time, and you will be able to fix those issues efficiently. So yeah. Lastly, just in summarization, if you actually just focus on those 4 things which I spoke about right now, you will be able to achieve all these plus points, and you will be able to boost your application and resolve at least 90% of those issues you are facing, and 10% you can keep working on. Thank you so much.
Thank you so much, Vibhuti.
If you have any questions, you can actually visit us on our Indie TV booth. Thank you so much.
All right. Next up, we have Ananyadeep.
Hey guys, hi. I am Anindyadeep, and I work as an ML engineer at Prem AI, mostly focusing on small language models and on-premise AI deployments. Today, I will be sharing with you a library that we have just released, which is fully open source, which is Prem SQL, and which mainly focuses on generative AI or any kind of RAG or kind of Q&A for specific to databases. And the reason we actually made Prem SQL is because when it comes to enterprise databases or any kind of data which is like super private, you cannot actually share those data or put those database or table information inside prompts which connects with closed source models, because it might lead to like lot of data breaches and security issues and compliance issues. And when it comes to actually creating open source solution, it's like, first of all, super messy, because you have like lot of options and it's like hard to build on top of it. And it's really hard to have data sets and fine tune models. You have infra problems, lot of stuff. And that is where Prem SQL actually helps, where we have just rolled out our first version of the library, which I will be coming up just after this slide. And other than that, we have also made a text to SQL model, which is just a 1 billion parameter model. And also like the first 1 billion parameter model, which achieves around like more than 50% accuracy, or 51.54 in, to be precise, in Bud Bench evaluation. It is like one of a standardized text to SQL like evaluation data set, which is like private data set, and they sort of evaluate everyone's approach. And we are one of the smallest model there. And the reason that that really helps is because you can actually try it out on your laptop, and it runs local. It is super fast, and you can actually build on top of it. Other than that, this is Prem SQL library, where we have created a very simple interface where you can simply connect with a database of your choice. Right now, we mostly support SQLite databases and Postgre. And other than that, all you have to do is connect with a client, which can be, which is mostly Hugging Face models, or you can also use our Prem SQL model, or you can use OpenAI if you want, if you know that your data is actually, not that much private. And you have to just query it, and it gives the result as a data frame. Other than that, the way that we, structured the whole library is, we saw that while creating any kind of generative AI, workflow or any kind of process, it needs to be structured, because it's like super messy around. So we have provided independent and modules which you can use independently, or use it with any kind of third-party APIs or whatever, where we have the generators, which basically is like we have made a good amount of abstractions, where you can basically connect any kind of client. It can be Hugging Face, it can be OpenAI, anything. We have also our data sets, which are basically a bunch of curated text to SQL data sets, because this is because here another thing, that text to SQL is actually not just your another LLM task, because here the goal is not just to generate any kind of random text which looks like SQL. You have to actually give a SQL which is executable, that executes into the database and gives out the right data frame, or like the right set of tables. So that is actually super important. So good data gives you good model, and obviously a good output. So we have all the data sets lined up. We have all the executors, which is basically connecting to your different kind of databases. And we have evaluators too, that evaluates the text to SQL models or any kind of workflow with like standardized evaluation benchmarks and suits. And finally, this is like our Prem SQL 1 billion model we just released in Hugging Face. You can also try it out. And as you can see, the best model out there, or most of the models out there, are actually built with GPT-4o, which is like 70%. We have reached 51%, and obviously this is our first release. We are aiming much higher, and obviously with open source models. And last but not the least, everything is fully open source, and you can also contribute to it and build on top of it with any kind of solutions that you're looking for. And also you can connect with me either outside or in Twitter, and also check out our models and GitHub, and let us know if you need to have any kind of features or anything. And obviously we are open for PRs and open source contributions. Thank you.
Thank you so much. Next up, we have Abhishek.
if I remove, it's the same. And then maybe slides. Yeah, hello, folks. Thanks for having me. I'm not going to take a lot of time. I know that I will let other speakers also respect the time. Hello, I'm Abhishek. I work at Tune AI, and we have built a developer platform called Tune Studio. And our primary goal is to help developers in the cycle of RLHF, and so that you can create data set, tune the models, and then later on you can serve / and then consume it through API. So the entire aim is that we help you through the entire loop. So that's Tune Studio. Please give it a try, and we support all the open source models. And in fact, you can bring your own model as well. And our moat is that we let you do fine tuning on a really good scale, and also with very cost effective way. Apart from that, we have a booth outside. We are running a contest. So if anyone is interested, like, they can participate in the challenge, and we have some amazing giveaways to give out as well. So again, thank you so much. Do come visit to the booth, and yeah, thanks.
Thank you so much, Abhishek. Next up, we have Dheeraj.
Good afternoon to one and all present here. My name is Dheeraj Shyam, and today my demonstration is regarding my own database engine that I have created regarding blockchain, that is the blockchain database. Currently, in the blockchain industry, there are many implementations, like for example, Solidity Ethereum, which is using LevelDB and data pages to maintain the data as well as state of this chain. But the only problem is that LevelDB is a key value pair, so that everything must be maintained in a serialized fashion by us. So I have observed this problem, and I have created a new database engine, which in turn manages the data on the disk in the form of data pages, which helps you in creating the blocks, maintaining the previous hash, and the link between everything. And the only responsibility by you is to provide the data to this engine, and the data engine responds to you that, okay, I've created the block and everything is ready now. So if you observe the architecture diagram, the data is being sent into the database engine, where in turn something called sequence is getting created. The sequence is something like tables in RDBMS, and database is something like schema in RDBMS. So when a data is sent, the engine checks whether if a data page is available or not. If not, then it creates a data page with a header stating that how much amount of space is there, how many number of blocks are there, what is the offset mapping, that is a cursor mapping of the particular block that you have created, and other related details. And your blocks will be serialized and kept in a serialized fashion, one after another. For suppose if your block having a data extended more than 8 KB, that is the no available space in the data page, then a leaf data page will be created and the data will be kept in it, but your block is just preserved in this data page. So if you observe the structure, the database structure is like this. It is having a header, block 1, block 2, and so on, the block n, and the naming convention will be like sequence name .0, sequence name .1, and etc. When coming to the sequence is a unit of storage, just like tables in RDBMS. Sequence uses sequence of data pages connected to each other, so that you can have a consistency of the data stored in it. And the data page is maximum of 8 KB, and as you can observe, this is the format of the header, magic number, version to avoid forward compatibility, free space, that is if 8 KB of space is available or not, and total number of blocks, that is how many blocks are stored in it. Currently, there is a limit of 8 blocks, as the header of a block is minimum of size 1028 bytes. So by considering it 8 KB and removing the 112 bytes that the header takes, that is the data page header, only 7 to 8 blocks can be accommodated. And the first page that is created .0 is something called Genesis page. And when coming to interacting with the database engine is completely isolated from the internet, so that we can have a clarity that, okay, no third party or authority is entering into our system and trying to access it remotely. So the another solution that we can have is to create an inter-process communication between the program or an SDK that is trying to communicate with this engine, and providing SDK in the programming language. Currently, the language I have chosen is Python because many of the websites in the world or AI models, etc., are implemented in Python itself. And the best benefit that you can get here is that when you're training your artificial intelligence model, you can say that, okay, I've created block 1 and block 2, connected each other, and I have kept patient X-ray data in block 1 and patient table data in block 2, and I can say my AI or ML model that, okay, you can analyze these two blocks and you can happily understand that the relation between the image data as well as structural data. And the way to interact with it is to import this particular library that I have created, PyAquaDB, the name of the engine that I have named it as AquaDB, from which you can import IPC and PyAqua table. It's a default implementation of data structure that you can use to store the data, or you can use anything that you want to put in it. The database engine uses data irrespective of the data type because everything is stored in the form of bytes, and the SDK or the programming language from which you're interacting with the database is responsible for managing this data. So if you observe the source code, you can understand how the interaction with the database engine works. And below output is a serialized form, and this one 307838306 is the serialized form, so that this will be sent as char pointer through IPC to the database engine to manage it in the form of blocks on the data, so that we can even create a brand new cryptocurrency and sign transactions like this in seconds, creating a brand new cryptocurrency with a faster transaction and signings. And you can create your own AI model even with it, as explained. So you can meet me in person outside. I'll be available or in this track 1. So if anyone wants to sponsor or collaborate with this, I'm always open for this. Thank you so much.
Thank you so much, Dheeraj. For the last lightning talk for today, we have Saurav.
Hello, good afternoon. So thank you for all who came to our booth today and yesterday who attended the workshop. So since it's about the lightning talk, so I don't have much time. So if I cannot answer some of your query, please feel free to connect me over the booth. Okay, so this is about the library that we have developed at NEC Japan Lab. So I'm from NEC Japan, and there we have been working on different research on data processing. So as you can see from this graph, this is the usual flow of the data that we gather the data from different sources. We prepare the data before the model can be trained, right? And research says that the most of the time that has been taken in the data preparation, that is around 70 to 80% of time that is being used. And the most important library that is still there and is being very popular, heavily used on a day basis. From the download, you can see that 100 million plus downloads are happening over months. But the important thing is that Pandas is slow, that is very well known to all of us. But the most importantly, it's not that it doesn't support multi-threading. It's not that it doesn't support good memory management. But it's that how well we can write a query that depends mostly the performance. Like the data flow optimization is something that is the core area of research where we have played and created our own library with the technology that I will be talking about. So, this is a very important slide. I believe you can pay attention, and if you still have any questions, so please connect me over the booth, so where I can answer you better. So here in this slide, what I'm trying to show is that when we usually load the data and try to solve some kind of query, in the slide, it is trying to have a data frame which is called DF, and it is trying to sort the data by a column, and then it is performing a filtration where the B is greater than 1, then getting the project. For example, okay, let's have the data. And let's have that the sorting order is something like yellow, red, green, and blue. So once I'll be asking it to sort the data, so it will sort my entire data. Then I ask it to filter the data, please. For example, filter this lighter gray part. So it will be filtering. Then it will project the target column and find the top 2. So the most important thing that is happening here is that since I'm working on the entire data, so my total data pipeline is going to have work on C column and D column, for example, in this data, which is never used like at the end of my result. So since it is not required, why to use it in my entire query? So for example, if I have 100 balls and after the sorting I want just have to 10 balls, so why not select the 10 balls and then sort? So that is the principle. The principle says instead of work on the entire data, first reduce the scope of the data. For example, here I'm interested in only A, B and E from the, for example, from the query you can see that A, B and E are the target column that I'm operating. So why not selecting those 3 columns first? Second, before doing the sort, which is an intensive operation, it's better than we should filter first because it will reduce the data in the row dimension. Okay. So once I have reduced the data in the columnar and row dimension, that is the data that is ready for my further computation. So in this way, if I can reorder my query by reducing the data in the row dimension, reducing the data in the column dimension, I would have the actual target area of data on which I can work. So that is the ideal concept of optimization data flow. So which is actually being used inside the library which we have introduced. The name is FireDux. So here Fire comes with the abbreviation like flexible IO engine for data frame. So at that moment, what happens? It have the pandas API, just an API which is for the compatible with pandas. So when you ask the API to be executed, we will create some intermediate representation using the LLVM framework. So once the intermediate representation is generated, what happens is that the compiler is there, which can inspect that what is your ideal objective and what is the data that of your interest. So it can create a better instruction. So once that instruction is there, it can be converted to pandas or any other library. So this is the principle that is working behind pandas, and based on it, it can be faster. So once again, why it is faster? First of all, it is lazy. So it tracks whatever you want to do, and the right time the JIT compiler will be triggered. It will be optimized, and the optimized code will be executed in the multi-threaded. So it will allow you to do faster data analysis. If you're working on cloud, it will reduce the cloud cost to a greater extent that we have in record. If you are working and thinking of the environment friendly thing, so it is definitely going to attribute less number of carbon dioxide. And if you're very known to pandas, you don't need to learn anything new. So that is what I can promise. So this is just a slide which shows that without any code changes, just changing the import, you can get small, like from 4 seconds to 275 milliseconds, so 15 times performance. That are the import by which we can import FireDux. Some benchmark which we have templates, so you can see that FireDux is performing very well in comparison to other library. Another benchmark. So these are some resources. So yeah, that's the end of my talk. So please feel free to connect me if you have any questions. I'm there in both. Thank you.
Thank you so much, Saurabh.
Hey folks, we'll connect back at 2:45 sharp for the next talk. So you can check the schedules and rearrange yourself in whatever tracks you want to go.